Okay, guys. We are continuing in lesson 6.6. Okay, as we continue in lesson 6.6, function operations, what we were working on yesterday. So we started yesterday talking about adding, subtracting. We started a little bit of multiplying, and now we're ready to talk about dividing. Okay, so if you look at C, they gave us F. They gave us G, and they asked us to find FG, which we already did yesterday, and now we have to find F over G. Now, to review, do you remember finding F times G? We did F, which was x squared minus 9, times G, which was x plus 3. And then in order to multiply those, we had to FOIL. So we FOILed, we ended up with that expression. Now, what about F over G, or F divided by G? We're going to start that way. X squared minus 9 is F, over x plus 3 is G. Now, notice, I said we're going to start that way. Okay? So we're starting with F over G. The key is always to simplify as much as possible. And I will be honest here and say there are right ways to simplify and get the right answer. There are incorrect ways to simplify. And so you need to make sure you understand how to correctly simplify. Now, I will also tell you, unfortunately, sometimes the incorrect simplifying steps will happen to get you the right answer. Okay? And in other words, there are times, like on this one, some of you are going to try and simplify one way, and I'm going to say, no, that's not right, but it's going to give you the right answer. It's not, though, because it won't always give you the right answer. It's coincidence. Okay? Okay, so thoughts on how to simplify x squared minus 9. Thanks for getting that out of the way. Okay, so Mackenzie's saying, well, what about 9 divided by 3? And if you're going to do 9 divided by 3, you might as well do x squared divided by x. But that's the wrong way. Okay? What you need to remember, okay, is that in order to cancel something, it has to be a factor. Or in order to divide something, it has to be a factor. Those x squared and the 9 and the x and the 3, they're being added and subtracted together. So you can't just take the x squared and the x and pull them apart from what they're being added and subtracted to and cancel them. Okay? Sometimes, I don't know if I've ever said it here or not, but sometimes we'll talk about when things are added and subtracted, they're married, and you can't break them apart. And that's the idea there, is that you can't take x squared and x and separate them from their other parts, their 9 and 3. So they have to be factors to be able to cancel. Okay? So, get that out of the way. Now, notice I kept talking about they have to be factors to cancel, yes? So let's think factoring. Can we factor that numerator? And the answer is yes. Whether you remember how to or not is a different story. But how does x squared minus 9 factor?
Oh, is it 3 and it's 3? X minus 3 and x minus 12.
It's coming to you. Okay. This is the difference of squares. Okay, it factors just like if it was like x squared plus bx plus c, except this is the difference of squares. X squared breaks into x times x, so the square root of x squared is x. What about 9? 3 and 3, or in other words, the square root of 9 is 3. And then how do you multiply to get a minus 9? You need a plus and a minus. So you end up with an x plus 3 and an x minus 3. And then my denominator was already an x plus 3. What do you notice here?
You can just
The x plus 3 in the denominator can cancel with, they have to be identical, x plus 3 in the numerator. Okay, it's identical factors cancel with identical factors. So one factor in the denominator cancels with one factor in the numerator. So x plus 3 cancels with x plus 3. And what remains as my answer? X minus 3. Huh?
She circled it.
That's a weird looking circle.
I boxed it as in that's the final answer of F divided by G. Yes, Caitlin.
I have a random question. Was that 5 always there?
Yes.
Oh.
I'm just noticing all the flags in the classes because I'm not here anymore.
Yeah, I'm not here anymore either, so it's weird.
Okay. I promise it's been there all year. Okay. Now, to finish off this question, we also have to talk about domain. We have to talk about domain of FG and domain of F divided by G. Before I do that, though, let's look at them individually real quick and talk about the domain of F and the domain of G. As you look at F was x squared minus 9. Are there any numbers we can't put in there? No. You can take any number you want, square it, subtract 9. So the domain of F is all reals. Let's also consider G. G was x plus 3. Are there any numbers I can't put in x plus 3? No, you can take anything you want and add 3. So domain of G is all reals. I mean, the two big things to watch out for, guys, square roots, which we had one of those yesterday, and denominators. Square roots can't be negative, denominators can't equal 0. Now, when we talk about the domain, we're going to have to split these up because we actually are going to have two separate answers here. So let's first do the domain of F times G. So when we do the domain of F times G, F was all reals, G was all reals. Look at FG. Does FG look like it would be all reals? Yeah, it's just x cubed, 3x squared, minus 9x minus, there's no square roots, no radicals or fractions. So the domain of FG is all reals. Now, the question becomes, and I had to separate this out for a reason, the domain of F divided by G. Sorry, that says all reals off the edge of the screen there, I promise. Okay, F divided by G. Well, again, F was all reals. G was all reals. How did F divided by G start off? It started off as a fraction. And I know it didn't end up that way, but it started off as a fraction. What is the issue with fractions? Specifically, denominators. Negative's not the issue. Denominators cannot equal 0. Okay? Right here, we had a denominator. And I know it simplified away later, but my problem started as F divided by G with that denominator of x plus 3. Are there any values that would make x plus 3 equal 0? Negative 3 would make this equal 0, wouldn't it? And so my domain's still going to be all reals, but it's going to be all reals except any number that made the denominator equal 0. And so when you have a denominator, what I'm going to tell you to do is take the denominator and set it equal to 0. So in this case, that means I'm setting x plus 3 equal to 0. And if you set x plus 3 equal to 0, what do you get when you solve? X equals negative 3. Which, because that was a denominator value, what we're really saying is that x cannot equal negative 3 in this problem. And so for my domain for F divided by G, I'm going to say all reals except x equals negative 3. All reals except x equals negative 3. Okay, you got what you need there? So for the most part, when we're adding, subtracting, multiplying, domain of F, domain of G, that's going to create your domain of the final result. Division, watch out for that fraction. Okay? Are we ready to try D? Natalie's just not having it today.
I don't understand this at all. I don't figure it out.
If there's a specific question you have, ask it.
I don't even know what question I asked really.
Okay, well, let's try the next one and see. Is it specifically about the domains? Is that where you're struggling?
Everything.
Everything.
I think we're in the
That's
same
just
spot.
all so. It's just a lot. I just don't.
Well, on the
I don't speak math.
adding, subtracting, and multiplying, don't make it harder than what it is. It's just adding, subtracting, multiplying. Now, the dividing, yes, we have to factor and think differently there. The domain's a little tricky. But parts of this are not bad. Parts of it, again, aren't the best. But parts of this are very doable. Okay? So let's look at D here. They give me an F. They give me a G. What do they ask me to find? FG. So how do I find FG? Okay, we're multiplying F and G, which F is 3x squared minus 11x minus 4 times G, which is 3x plus 1. Okay, so this, as I said, this is where I said don't get hung up on it's F times G and all that. You guys know how to multiply this stuff. Ezra used the word FOIL. Technically, we can't exactly FOIL, but it's the right idea. Okay, officially, I'm going to say we need to distribute. And I only say technically we can't FOIL because one of them is a trinomial. It has 3 terms instead of 2 terms. Okay, so let's multiply. I'm going to start with my 3x squared and distribute. 3x squared times 3x. 9x cubed, yep, add those exponents. 3x squared times 1. 3x squared. Now I'm going to take negative 11x and distribute. Negative 11x times 3x. Negative 33x squared. Negative 11x times 1. Minus 11x. And now, don't stop there. We're going to distribute negative 4. Negative 4 times 3x. Minus 12x. Negative 4 times 1. Minus 4.
I don't like that.
Okay. Take one more step. Is there cleanup that can be done?
3x minus 33x.
9x cubed is going to stay 9x cubed. 3x squared minus 33x squared. Minus 30x squared. Minus 11x minus 12x. Minus 23x and still minus 4. There is your F times G. That's multiplying. That's stuff you've been doing since technically Algebra 1. That's doable. You just have to put the effort in. Okay. You ready for the next part? We just found F times G. Now we need to find F divided by G. So F divided by G means I'm setting up what? 3x squared minus 11x minus 4 over 3x plus 1. Okay, any thoughts?
There's an x squared. Of course, we have 4
So yeah, can we
factor?
Okay, we have to try and factor, okay? As it is right now, all terms are just added and subtracted. So no, you can't cancel any 3x's here. That's a no-go. Okay, so we're going to have to think factoring. Now, my denominator of 3x plus 1 is 3x plus 1. My numerator, it's of the form ax squared plus bx plus c, which means we're going to have to factor. And with any luck, this is going to factor into 2 parentheses. Now, what's the catch?
It's a triangle.
Okay, there's a 3 out front. It's 3x squared. Now, we can't just take the 3 out front, though.
It's 11.
What's our form? We have to do product of AC. I don't know where you got the squared from, but product of AC. So, I don't really have room, but I'm going to kind of write it down here. Product of AC. 3 times negative 4. 3 times negative 4 means I'm going to need a product of negative 12. A sum of B, which is negative 11. What multiplies to be negative 12 and adds to be negative 11? Okay, negative 12 and 1? Because it's 12 times 1 somehow. If it multiplies to be a negative, one of them is negative. If it adds to be a negative, the larger number is negative. Yes? Okay, now here's the deal. What do I do with that in product of AC? Take your middle term and split the middle term. Remember, you take that negative 11x and you split it. So I'm going to rewrite it down here. It's still 3x squared, but instead of minus 11x, I'm going to write minus 12x plus 1x, and then we still have a minus 4. We've done this year. I have taught this to you this year. This school year. Sorry. I got to protect myself from Ezra being contrary. Okay, so we have 4 terms. What do? Split it in half. First 2 terms. These first 2 terms, you can factor out, focus up here please, a 3x. 3x squared divided by 3x leaves me with x minus 12x divided by 3x is 4. Second 2 terms, or last 2 terms. GCF between 1x minus 4. If all else fails, there's a GCF of 1. So I'm going to write plus 1 here. But when I divide those by 1, I'm still going to have x minus 4. Remember my matching parentheses? One of my parentheses is x minus 4. Matching parentheses. The other parenthesis is 3x plus 1. You've been there. You've done that. Those of you getting ready to I-step, yes, factoring is expected. Yes, this type of factoring is expected to be known. Okay. So that was a good review. Now, what just so happened to work out? We have a 3x plus 1 that can cancel. So what does this equal? X minus 4. I'm done with that part of the problem. I'm not going to set that equal to 0. Hold that thought. Okay. Now, we need to go over and talk domain, yes? Let me zoom back out some here. So, domain. Again, I like to try and individualize here a little bit. Domain of F. Basically, were there any square roots or fractions in just f that caused problems? No. F is all reals. You could put any number you need in f. Okay, G. Were there any fractions or square roots in G? G was just 3x plus 1. So G by itself is all reals. Now we need to talk about FG. F was all reals. G was all reals. We multiplied those and we got FG, which is this expression here. Any square roots or fractions I have to watch out for? No, so FG is all reals. And then lastly, we have to talk about the domain of F divided by G. Okay? F was all reals. G was all reals, but then we divided. Our answer was not a fraction, so our answer is fine, but go back and look. We had a fraction here. What's an issue with a fraction? Denominator cannot equal 0. So what do I do to find my excluded value? Set the denominator equal to 0. So you're not saying your answer equal to 0. You're saying your denominator equal to 0. So if it's 3x plus 1 equals 0, subtract 1, 3x equals negative 1, divide by 3, and x is negative 1/3. Or in other words, x cannot equal negative 1/3. So I'm going to say all reals except x equals negative 1/3. Okay, get what you need there. We're going to flip to the back. We should get through most, if not all of the back. If we don't get through the bottom, you'll still be fine. The front was add, subtract, multiply, divide. The back is something called compositions. And I don't know, I don't really think you've seen much in the way of compositions before. I refer to these as Fogg and Goff. And so the idea of composition of functions. First of all, notice there's a little dot between f and G and f. It's not a multiplication dot, though. It looks like a little degree bubble, but I call it a composition circle. It's just a little open circle, and it means composition. Okay, now what that means, so right here, Fogg, f composed with g of x, means I'm going to do f of g of x. And basically what it means is we're going to take g and we're going to plug it into f. And I will walk you through this step by step. Okay? When you see Goff, where it's g composed with f of x, that's g of f of x, and that means, notice this time, f is in the inside. So we're going to take f and we're going to put it into g. Okay? Now, give me a fresh slate in your head, okay? And let's try example A. I'm going to walk you through this step by step. Okay, so they give me an f of x, they give me a g of x. Keep in mind, you'll always be given f and g. They won't always be the same, but you'll always be given f and g. The first thing they're going to ask us to find is Goff of negative 3. Or G composed with F of negative 3. First thing I'm going to do is I'm going to rewrite it like what we see up above. So if you look up above, G composed with F of X is G of F of X. Down here, G composed with F at negative 3. I'm going to rewrite this as G of F of negative 3. So I'm just using the definition of composition there. G composed with F is G of F of whatever that input value is. Now, like anything, when you see lots of parentheses, where are we supposed to start? On the inside? So the inside piece I want you to look at right now is F of negative 3. Do you remember how to find F of negative 3? I have taught you this year. If we're finding F of negative 3, that means we're going to take F, and every place we see an X, we're going to replace it with negative 3. So if F says to do X minus 5, I'm going to do, instead of X minus 5, negative 3 minus 5. So I'm going to take this negative 3 and put it into F here. So F is X minus 5. I'm going to do negative 3 minus 5. What is negative 3 minus 5? Nope. Negative 3 minus 5 is negative 8. Yep. Okay. Now, that was the insides we just did. We used F and we plugged in negative 3. So we did negative 3 minus 5. What was outside of F? G. So now we're going to do G of negative 8, which now we're going to look at our G definition, and every place you see an X, we're going to replace it with negative 8. So G says to do X squared, which means I'm going to do negative 8 squared. What is negative 8 times negative 8? 64. And you're done. I went ahead and boxed it. No questions about it.
Wait, that's
the answer.
Entire problem.
That's the entire problem for GOF of negative 3. Now keep in mind, they ask like 3 different questions in this problem.
That was too easy.
That was just doing what is G composed with F at negative 3. Okay. Please continue to give me a chance. Well, here's what I'm going to tell you guys. If you shut me out and say, I can't do this, this is too difficult, you have no chance of figuring it out. Correct? If you continue to be open-minded and give me a chance and practice with me, you have a chance of still figuring it out. It is doable, I promise. Okay, let's try the next one. Unless you had any specific questions there. If you're just confused and don't know what questions asked, then try the next one with me. Okay? What's the next question? Fog of negative 3. Now, first thing I'm going to do is I'm going to rewrite it. F composed with G means I'm going to write F of G of negative 3. Start where? We're going to start on the inside with negative 3. And that negative 3 we're going to put into which function? G. So we're putting negative 3 into G. What was G? X squared. So if we're doing G of negative 3, Instead of x squared, we're going to say negative 3 squared. So I put negative 3 into the g equation. What is negative 3 squared? 9. Okay. Now, I'm not done because I only did the insides. I only did G. Now what do I have to do? F. So we're going to use this new inside number of 9, and we're going to look at F. So it's F of 9. So what does my F equation say to do? X minus 5. What are we going to use as X? 9. And so we're going to do 9 minus 5, which is 4. Say what now?
So negative 3 in all of both the equations is x.
Yes, they went ahead and gave us our X as negative 3.
So whenever they talk about x minus 5 as an example, so it's negative 3 minus 5.
Uh-huh. Yep. Okay, we ready to try the next one? So Caitlin's got it all figured out with negative 3's back there. And this last one we're doing on this row, we're going to use A. There isn't. Okay, so we're going to do GOF of A. So last time it was negative 3. Every place we saw X, we put negative 3. This time, every place we see X, we're going to put in A. Okay, so GOF means G of F of A. And I'll be honest, I'm more concerned that you can do this with numbers, but it's still good to practice and try it with variables. Okay, so if I start on the inside, F of A. Okay, F, if you look at F was X minus 5, so my X becomes A, and it is A minus 5. Now, normally I clean up at this point. What is A minus 5? A minus 5. There is no cleanup. Good. Okay. That was doing the insides, which was F. Now I'm going to do the outsides, which is G. What is my new inside amount? A minus 5. So I'm going to take A minus 5 and put it into G. What is G? X squared. So we're going to take this value and square it, which means I'm going to say A minus 5 quantity squared. And in all honesty, on this particular problem, I left it as is. I left it as A minus 5 squared. Now, if necessary, could you write out the two side by side and FOIL them together? And that could be necessary depending on the problem. Okay? On this particular one, I left it like this. Okay?
So A is 15.
Mm-hmm. Because that's the problem they asked us to do.
You don't square it until after.
It's all about going in this order, the steps they give you. Now, we've got a couple more minutes. So I'm going to try a little bit on the next row. Just, I feel like you guys need some practice. Okay? I can't help a nap issue. Okay. Now, on row B, notice they give me a new F and a new G, yes? They'll always provide that. The first one they ask us to do, fog of negative 2. So fog of negative 2 means F of G of negative 2. Where do I start? inside with g of negative 2. So that means negative 2 becomes my x in g. What's g tell me to do? Nope. X minus 2. We have a new g. It says x minus 2. So my x is negative 2. So negative 2 minus 2, which is negative 4. Do I box it? Not done yet. Now we have to find f of negative 4. So negative 4 is our x in the f function. What's f tell me to do? Square it and add 1. X squared plus 1. So I'm going to say negative 4 squared plus 1. Negative 4 squared is 16 plus 1 is 17. I feel like it's starting to come together.
This makes a little more sense.
I mean, I'm doing it, but I don't know. I still don't know.
Well, I started out, I thought you said golf, and I was so confused.
Hey, if you spin a real world situation, what is this used for?
I don't have one for this.
Yeah.
I don't. Okay. I mean, I think it's more about understanding how to work with equations and where we go in algebra, but I don't have a real world for this one. Okay. Here, let's try this one real quick. Goff of 5. G composed with F. So G of F of 5. Start with F of 5. So 5, put it into F. What was F? X squared plus 1. So that means I'm going to do 5 squared plus 1. And 5 squared plus 1 is? 26. And now, we haven't done G. G of 26 means 26 goes into G. What's G? X minus 2, so 26 minus 2, which is 24. Okay, guys, the bell's going to ring here, so I'm going to have to stop there. I can tell you the answer for the last one if you want to try it. And this is the non-multiplied out answer. So if you did fog of A, you would end up with that answer. Now, folks, homework. Try it. It's due tomorrow. Okay? Lesson 6.6, do it. Due tomorrow.
It is wonderful.